The ancient dance between light and dark. In the beginning, there was only light and darkness, cycling endlessly as our planet spun through the void of space. For billions of years, the Earth has completed one full rotation every 24 hours, bringing each hemisphere from brilliant daylight into the embrace of darkness and then back again. This celestial dance didn't just create day and night, it created the fundamental rhythm that would shape all life on Earth. Everything about who we are, how our bodies work, and why we cannot escape the pull of sleep when darkness falls, traces back to this ancient, unbreakable pattern written into the code of every living cell. We are not simply creatures who happen to sleep at night. We are being sculpted by the turning of the world, our biology intimately woven into the fabric of planetary rotation, our consciousness rising and falling with the sun. Long before humans walked upright, before mammals ruled the land, before even the dinosaurs claimed their dominion, the earliest life forms on Earth were already adapting to this rhythm. Simple organisms, floating in primordial oceans 3.5 billion years ago, developed internal clocks to anticipate the coming of daylight and the arrival of night. These weren't conscious decisions or learned behaviors. They were survival mechanisms etched directly into DNA. The organisms that could predict when the sun would rise were the ones that thrived because they could prepare their cellular machinery in advance, timing their metabolism and reproduction to the most advantageous moments. This biological timekeeper, refined across countless generations and billions of years, still ticks inside you today. The same fundamental mechanism that helped ancient bacteria survive in a harsh primordial world now governs when you feel alert, when you feel hungry, and when you feel irresistibly drawn towards sleep. Your body doesn't simply react to darkness by becoming sleepy. Instead, it maintains an internal clock, a master timekeeper located in a tiny cluster of about 20,000 neurons in your brain called the suprachiasmatic nucleus. This remarkable structure, no larger than a grain of rice, sits just above the point where your optic nerves cross, receiving direct input from specialized cells in your eyes. These aren't the cells that allow you to see images, recognize faces, or read these words. They're intrinsically photosensitive retinal ganglion cells, and their sole purpose is to detect the presence or absence of light, particularly the blue wavelengths that dominate daylight. Even people who are completely blind, unable to perceive shapes or colors, often maintain normal sleep-wake cycles because these specialized cells continue to function, sending signals about light and darkness directly to that master clock in the brain. This is why a blind person can still feel sleepy at night and alert during the day. Their bodies are still receiving the most fundamental signal of all, whether it is day or night outside. This internal timekeeper doesn't run on a precise 24-hour cycle. And this fact reveals something profound about our relationship with the natural world. In the 1960s, scientists conducted experiments where volunteers lived in underground bunkers with no access to natural light, no clocks, and no way to tell time. Something fascinating happened. The participants' natural sleep-wake cycles began to drift, settling into a rhythm that averaged about 24 hours and 11 minutes. Some individuals stretched closer to 25 hours. Without the daily reset that light provides, the human body's internal clock runs just slightly longer than the Earth's rotation. This is why we need the night to fall, not just to trigger sleep, but to synchronize our internal rhythms with the external world. Every morning when light enters your eyes, it resets this clock, pulling your biology back in line with the planet's 24-hour day. Without this daily correction, your sleep schedule would slowly drift later and later, eventually becoming completely misaligned with day and night. You would find yourself wide awake at 3 in the morning and desperately tired at noon. As darkness descends and those specialized cells in your eyes stop detecting blue light, a cascade of biological events begins to unfold with the precision of a Swiss watch. The suprachiasmatic nucleus sends signals to a pea-sized gland deep in your brain called the pineal gland, releasing it from daytime suppression. The pineal gland then begins to secrete a hormone called melatonin into your bloodstream. This isn't the melatonin you might buy at a pharmacy in pill form. It's your body's natural version, released in carefully calibrated amounts that rise and fall with perfect precision throughout the night. Melatonin doesn't knock you out like a sleeping pill. Instead, it opens what scientists call the sleep gate, a window of time when your body becomes receptive to sleep. Your core body temperature begins to drop, decreasing by about 1 to 2 degrees Fahrenheit throughout the night. Your blood pressure lowers, your heart rate slows, your metabolism downshifts. Every system in your body begins to shift from the active, alert state of daytime into the restorative, regenerative state of nighttime. This cooling of your body temperature isn't a side effect of sleep. It's actually a crucial trigger, one of the most important signals your body needs to initiate sleep. Your body needs to shed heat before you can fall asleep, which is why hot, stuffy rooms make it so difficult to drift off, and why a cool bedroom promotes better sleep. The drop in temperature is regulated by your circadian rhythm and begins before you even feel sleepy, starting in the late afternoon and early evening. Your hands and feet actually become warmer as bedtime approaches, as blood vessels near the skin's surface dilate to release heat from your core. If you've ever noticed your feet feeling warm in the evening, this is why. Your body is redistributing warmth, pushing it to your extremities so it can radiate away, cooling your core to prepare for sleep. This redistribution of warmth is one of the first physical signs that your body is preparing for sleep, usually starting about an hour or two before you naturally feel drowsy. Ancient humans didn't have thermostats or air conditioning, but they had the night, and as the sun set, the temperature naturally fell, helping to facilitate this essential cooling process that made sleep possible. The relationship between light, darkness, and sleep is so fundamental that it affects not just when you sleep, but how well you sleep and how you feel when you wake. Exposure to artificial light after sunset, particularly the blue wavelength light emitted by phones, tablets, computer screens, and LED bulbs, tricks those specialized cells in your eyes into thinking it's still daytime. They send signals to your suprachiasmatic nucleus, indicating that the sun hasn't set, which, in turn, suppresses the release of melatonin from your pineal gland. Even brief exposure to bright light in the evening can shift your circadian rhythm later. delaying the opening of that sleep gate by an hour or more. Studies have shown that using a tablet or smartphone for just 2 hours before bed can suppress melatonin by approximately 23% and delay its release by about 90 minutes. This isn't about willpower or discipline, it's about biology. Your brain is receiving conflicting information. The clock says it's 10 p.m., but your eyes are reporting midday light levels. The result is a body caught between two states, neither fully awake nor ready for sleep, a condition that has become epidemic in modern society and contributes to the chronic sleep deprivation affecting millions of people. Our ancestors didn't face this conflict. For hundreds of thousands of years, humans lived in perfect synchronization with natural light patterns. When the sun set, darkness fell. Complete, enveloping darkness, broken only by firelight. Fire produces light primarily in the red and orange wavelengths, which don't significantly suppress melatonin production the way blue light does. Sitting around a campfire in the evening would have provided light to see by and warmth to gather around, but it wouldn't have disrupted the biological preparation for sleep. The darkness that surrounded that circle of firelight was absolute, and it sent unmistakable signals to every person's circadian system. Night has arrived, and sleep will soon follow. This wasn't just tradition or culture. It was biology in action, the same biology that still governs your body today, even though the environment you live in has changed dramatically. Your genes are still calibrated for a world without electricity, without smartphones, without the ability to turn midnight into artificial noon at the flip of a switch. The discovery of how profoundly light affects our sleep came relatively recently in human history. For centuries, people understood that they slept when it was dark and woke when it was light, but they didn't understand why or how the mechanism worked. The pathway remained mysterious until the 1980s, when researchers began to map out the neural connections from the eye to the suprachiasmatic nucleus. And then later in the early 2000s, when they discovered the specialized photosensitive cells that detect light independently of vision. Before electric lighting was invented just over a century ago, humans maintained sleep patterns that were remarkably consistent with our biology. Historical records, including diaries, legal depositions, and literature from the pre-industrial era, reveal that people often experienced what was called segmented sleep. They would sleep for 4 to 5 hours after darkness fell, wake naturally for an hour or two in the middle of the night, during which they might pray, read, have intimate conversations with their partners, tend to the fire, or even visit neighbors, and then return to sleep for another 4 hours before dawn. This pattern, strange as it seems to modern sensibilities, was perfectly aligned with natural melatonin rhythms and the slow ebb and flow of the hormones that govern sleep and wakefulness. The need for darkness doesn't end once you've fallen asleep. Throughout the night, even the smallest amounts of light can disrupt your sleep architecture and reduce sleep quality in measurable ways. Light exposure during sleep suppresses melatonin production, signals your brain that it might be time to wake, and can pull you out of the deeper, more restorative stages of sleep into lighter stages, or even brief awakenings that you won and remember in the morning, but that fragment your sleep nonetheless. Studies using polysomnography, comprehensive sleep monitoring, that measures brain waves, eye movements, muscle tension, heart rate, and breathing, have shown that people who sleep in completely dark rooms spend more time in slow-wave sleep, the deepest stage where the most crucial physical restoration occurs. Even ambient light levels, as low as 5 lux, about the brightness of a nightlight or the glow from a digital alarm clock, can measurably affect sleep quality and hormonal balance. Your eyelids aren't completely opaque. Light can penetrate through them, reaching those photosensitive cells even while your eyes are closed. This is why humans naturally seek dark spaces for sleep, why we've always retreated into caves, huts, tents, and darkened rooms when night falls. We instinctively understand what science has only recently confirmed. Darkness isn't just the absence of light. It's an active requirement for proper sleep. The darkness of night serves another crucial function beyond triggering melatonin and opening the sleep gate. It protects the delicate processes of sleep itself. Sleep isn't a single uniform state where you simply lose consciousness for 8 hours. It's a complex journey through multiple stages that cycle throughout the night, each serving different purposes. You begin in light sleep, progress into deeper slow-wave sleep, where your brain waves slow to long, synchronized rhythms, and then enter REM sleep, where your brain becomes nearly as active as during waking hours while your body remains paralyzed. This entire cycle takes about 90 minutes and repeats 4 to 6 times each night, with the proportion of each stage shifting as the night progresses. In the first half of the night, slow-wave sleep dominates. This is when your body repairs tissue, builds bone and muscle, strengthens your immune system, and clears metabolic waste from your brain. In the second half of the night, REM sleep takes over. This is when your brain consolidates memories, processes emotions, forms new neural connections, and integrates the experiences of the previous day into your existing knowledge and understanding. Both halves are essential, and both require the continuous protection of darkness to proceed undisturbed. The evolutionary pressure that created our dependence on nighttime sleep was intense and unforgiving. Early mammals emerged during the age of dinosaurs, and most of them were small, nocturnal creatures who lived in the shadows, venturing out only under the cover of darkness, when the giant reptiles that dominated the world were less active. As mammals evolved into the diverse forms we see today, including the primates that would eventually become humans, many species shifted to being active during the day, taking advantage of better vision and the ability to see in color. But the night remained essential for sleep, carved out as a sacred time for rest and repair. Animals that couldn't maintain proper sleep-wake cycles, that couldn't retreat into safe darkness to sleep, didn't survive to pass on their genes. The trait was so critical that it became hardwired into the deepest levels of our biology, governed by genes with names like clock, BMAL1, purr, and cry. Genes that exist in nearly identical forms across a vast array of species, from fruit flies to mice to humans, all maintaining the same basic function of timekeeping that evolved billions of years ago in those ancient single-celled organisms floating in primordial seas. What makes human sleep particularly dependent on nighttime darkness is the unique vulnerability of our species during sleep. Unlike many animals that can sleep while standing, or while partially alert to danger, or in brief naps scattered throughout the day, humans require long, consolidated periods of deep unconsciousness. We are profoundly defenseless when we sleep. We cannot run from predators, we cannot defend ourselves effectively. We lose awareness of our surroundings, and we're completely vulnerable to any threats that might emerge in the darkness. This extreme vulnerability meant that our ancestors could only afford to sleep when it was relatively safe to do so, and for creatures with limited night vision like humans, that time was the dark hours when everyone else, including predators, also had limited vision, when threats were no longer at such an overwhelming advantage. We became locked into nighttime sleep, not just by our circadian biology, but by the practical reality of survival. We needed darkness to level the playing field, to create a time when it was acceptable to be vulnerable, because everyone else was vulnerable too. This vulnerability during sleep is why humans developed such sophisticated circadian systems, more elaborate than those found in many other species. Your body doesn't just track whether it's day or night. It tracks the progression of the day, the angle of sunlight as it arcs across the sky, the gradual dimming toward evening, and uses all of this information to prepare for sleep hours in advance. The process of falling asleep doesn't begin when you close your eyes. It begins in the afternoon and early evening as your body gradually transitions from the active phase of your circadian rhythm to the rest phase. Cortisol, the hormone that promotes alertness and activity, follows a predictable daily pattern, peaking in the early morning to help you wake up and gradually declining throughout the day. By evening, cortisol levels have dropped significantly, removing one of the barriers to sleep. Meanwhile, adenosine, a chemical byproduct that accumulates in your brain during waking hours, has been building up all day. Adenosine is like a biological accounting system of how long you've been awake. The longer you're up, the more it accumulates, and the stronger the pressure to sleep becomes. This is why you feel progressively more tired as the day wears on, even if you're not physically exhausted. The intricate choreography of hormones, neurotransmitters, and neural activity that culminates in sleep requires darkness as its cue, its signal that the time has come to begin this nightly transformation. Without that signal, the choreography falls apart. People who work night shifts and attempt to sleep during the day face a constant battle against their biology. Even after years of working nights, most people never fully adapt because they're exposed to daylight during their commute home or through their bedroom windows, preventing their circadian rhythms from completely flipping. The result is a perpetual state of circadian misalignment, where their internal clocks say one thing and their schedules demand another. This misalignment has measurable health consequences: increased risks of cardiovascular disease, metabolic disorders, obesity, diabetes, depression, and even certain cancers, all stemming from the disruption of natural sleep-wake rhythms that evolved to align with the planet's cycle of light and dark. The International Agency for Research on Cancer has classified shift work that involves circadian disruption as a probable carcinogen, putting it in the same category as exposure to certain chemicals and ultraviolet radiation. Every discovery about sleep and circadian rhythms points back to the same fundamental truth. We are children of the Earth's rotation, creatures shaped by billions of years of exposure to the predictable cycle of day and night. The darkness isn't just the absence of light. It's an active signal, a daily reset button that allows our bodies to transition into a completely different state of being. When night falls and we surrender to sleep, we're not simply resting or taking a break from waking life. We're participating in an ancient ritual encoded in our genes, responding to signals that have meant time to sleep for as long as life has existed on this planet. The falling night doesn't just make sleep possible, it makes sleep what it needs to be, a time of profound restoration, protected by darkness, synchronized with the cosmos, as essential to our survival as food, water, or breath itself. When you understand all of this, the ancient evolutionary history, the intricate biological mechanisms, the profound consequences of disruption, you begin to see sleep not as an inconvenience or a waste of time, but as what it truly is, one of the fundamental pillars of human existence. We cannot override it with willpower or replace it with technology. We cannot cheat it or negotiate with it. We can only honor it by giving our bodies what they need: darkness when night falls, light when day breaks, and respect for the ancient rhythms that have governed life on Earth for billions of years. The night doesn't fall to make us sleep. We sleep because the night falls, because we are creatures of this planet, bound to its rhythms as surely as the tides are bound to the moon, as surely as the seasons follow the tilt of the Earth's axis. In sleep, we return to something older than consciousness itself, older than thought or language or civilization. We return to the fundamental pulse of existence, the eternal alternation between light and dark that has shaped everything we are. Each night, you travel through stages and cycles, through dreams and deep rest, through a carefully orchestrated process that has been refined over millions of years of evolution. You don't have to understand it all. You don't have to control it. You just have to let it happen. Your mind knows what to do. It has been doing this your entire life. It will guide you through the stages, give you the dreams you need, provide the rest that will restore you. All you have to do is close your eyes and let yourself drift. Rest now. Your body is ready. Your mind is ready. Everything that needed to happen today has happened. Tomorrow will take care of itself. For now there is only this moment, this breath, this gentle descent into sleep. Let yourself go. Let the darkness hold you. Let sleep come. You